So it actually has an occasion to quickly deep dive into Grok 4, these large intelligent models that are coming out, for example, in this case, XAI. We have some philosophical discussion quickly on that. And then we go into more details of how you can leverage these large models in a composition way to build potentially cutting edge and corporate ready software. But maybe, Joao, just for the first notion, Grok 4 came out. What was your first impression, kind of ideas when you saw it? I think we both were fairly excited, but what was your best take on Grok 4?
I mean, I'm always skeptical with seeing the benchmarks, especially when they're released by the company announcing the model, because it's usually some version of, here's the current benchmarks, here's us, slightly better than everyone else. And then you look at the graph and you see like the y-axis is a bit skewed, and the graph itself is made to make your model look better. But even then, I think Grok 4 has been looking pretty good. I mean, the stats on it, how intelligent it is and how good it is at using tools, it's pretty good. Especially because Grok and XAI in general has been a bit left behind in terms of the top players in the market. We've been talking about Gemini from Google, Anthropic and OpenAI have been like the top 3 players, and XAI with Grok making a comeback to, let's say, the leaderboard of the top 4 or top 3 models. So it's good to see some competition in the space. However, they made a comeback pretty quickly. And to do that, especially with the size and funding, you can't buy time, so you have to skip some steps. And I think that the news we were seeing on X or Twitter with they're changing the prompt and having XAI or having Grok sound a bit like Hitler, or announcing himself that to be the new Hitler or Mecha Hitler. I mean, that's just one of those basic things that you should test for.
I mean, it's usually cutting a little bit corners, right? Maybe just for the audience, Grok 4 is the latest model by XAI, and they just took sometimes, probably most likely, a little bit of a different approach. I actually maybe can put it on the screen here. The bitter lesson is an essay I've had seen at university many years ago. I think it came out like 6 years ago. And this essay basically talks about the notion of you either have human intuition, human intelligence built into the model, so you make it a little bit human-like. Maybe just for the reference here, that might be going into the labeling of the problems you're training the model on, or maybe in the reinforcement learning. So you basically try to take all the human intelligence and you kind of try to make the artificial intelligence like that. So this was like one of the notions. The research, though, in the last 70 years, and that's basically the core idea of the essay, is like if you throw just a lot of compute at a model, aka chips, in today's world, most likely NVIDIA chips, it's yielding better results than human intuition. And that humans are just sometimes believing, at least that's based on the essay, that we can inflect our intelligence into the AI, and that's the better approach. But again, the rather better approach is most likely yielding better results where we have more computation, more chips, more electricity, and maybe more data. And that's basically what's happening maybe with Grok 4 as well, because they had to catch up. So they maybe had to take different design considerations. And in this component, maybe put that on the screen as well, XAI had built this huge data center called Colossus, 100,000 NVIDIA chips, maybe scaling up to 200K, maybe 1 million, potentially this year already. And then just actually threw that whole computation on these transformers, and they kind of figured it out in the first place, as opposed to maybe more a nuanced way, like OpenAI took, maybe like Meta is taking, where we have labeled problems, labeled data sets, really human, again, injected intelligence. And I just found particularly that component fascinating, that you can just scale up compute, and then it kind of works out. Because I mean, we anyway never know. Yeah.
Compute does scale, but it has like a cost, right? I mean, we already have immense like power bills and the cost for the data centers, not only for the power, but also to cool the chips. And so you can scale these data centers to a point, you can scale these models to a point, but it'll be hard to keep going after, I'd say, when you get into millions of chips, I think then we're talking about like billions of dollars or euros invested into data centers. And so it starts to become harder and harder for new competitors getting into the game, because no one will have a data center in their pocket ready to go. And also these models, like, they can only get so big, right? But that has been the trend. I mean, even before we had LLMs, one of the big breakthroughs we had was building data sets synthetically and using models for reinforcement learning. So basically not just using data sets we had, but using models to create new data sets and train them on the data sets in a single loop. And so having that kind of architecture then be applied to LLMs, if you look at the history of AI, it all seems like it was leading up right up until this moment. So it is scaling. It is like a pretty fast way of scaling. Just make the models bigger.